We will start today with a very new topic, Docker. Our speaker today, the first one, is Tobias Schwab. And have fun.
Thanks. Yeah, hello. How was the party yesterday? Nice view, right? Little applause to the organizers. I really liked the venue, and one could probably see most of Berlin from like one floor, which was really nice. All right, a little bit about myself. I'm Toby. I'm from Hamburg. I run a Rails consultancy, basically software consultancy. I used to be a Ruby developer, Rails developer for a long time, but then suddenly I turned ops, basically overnight. And that was like 2 years ago, I think. Who remembers the leap second bug here? Who was affected by it? Yeah, most of them. All right, the same happened to us. We were running Ruby on Rails, which is normally not that close to Java, but we also had Solar running in our setup. So suddenly I woke up at, Sunday in the morning or something like that. The site was down, and I was like, what the heck? I was like doing ops in my spare time at the project because it wasn't that big, but yeah, in that case, it took me quite some time to figure out what actually the problem was. And then I looked at Twitter and my peer groups, and then I found like leap second bug, all right, restart all the JVMs, restart the machines, and that was all fine. But that was not the point when I turned ops. That was the next day after that, because then we had TV coverage with our application we created, where it was just like 2 days in a row. And so we had TV coverage on RTL Extra, and we were running a apartment rental service platform, and they were like, all right, you can book really good places with that rental platform. And yeah, so we had coverage, and the site was down, so were the competitors, so it was not that big of a deal. And we said, all right, if the people calm down and it's like 12 the next day, everything will be fine again, but it wasn't. The problem was that just because of that TV coverage, we had like 3 times the traffic this week we had, because the people went to the office and they told their colleagues that this is a really nice platform and you can do crazy, book really good apartments in Berlin and wherever. And so we had 3 times the traffic, but we were running on like dedicated machines, and the ops setup was not that solid, so that we need to extend the capacity by like at least, I mean, we were not running at 100% before that, but we had to run at like 300%. So we had to add capacity. We were hosted with Rackspace, so they had a cloud platform, but it took us really long to basically add these new servers, and it was like at least 1 week completely nightmare. We had to fix code, and so I realized you have to do that stuff like that in advance. So you have to basically take care of that, because this week I don't want to have again any more. So then I decided, all right, someone has to do it, and so I said, all right, now I'm the ops guy, and I was basically the ops guy for most of our projects. All right, so when it comes to ops, we have like kind of a strict philosophy. We're like Ruby on Rails developers, so we are agile people. We want to ship, and we also follow continuous delivery. Who knows continuous delivery here? All right, most of them. All right. I think it's the phrase is coined by ThoughtWorks, which means it doesn't mean continuous deployment. It doesn't mean every time you commit something and every time the build is successful, you deploy that build. That just means you could if you wanted, and you should be able to do that in like a fraction of the time. So every time the build is green, someone should say, all right, let's deploy that. And we deploy multiple times a day. So we want to try to have the change set we use to be as small as possible, because the smaller, the less often you get errors. And if you get errors, you know exactly what happened, basically. So yeah, we deploy multiple times a day. I will show that in some graphs later on. Yeah, and we also do canary releases. Who is doing canary releases here? Anyone? Who knows about canary releasing? Okay, so a little explanation. Canary means probably the wrong pronunciation, but I don't care. It is metaphor for the canary in the coal mine, which means back in the days, the people had the canary in the coal mine, and if the oxygen level went down, this canary died. So you basically you said, all right, that's like our collateral damage. We lose this one canary, but we all survive. So in that case, we do deployments, which means we deploy to one group of servers first. We look at the application there. If the application there dies, we're afraid and we stop the release, for example, and we roll back. So we deploy to a group of servers, and then we increase the group size, and we try to figure out in our metrics. I mean, we don't do much QA, to be honest, because we have quite a solid test suite, and we're quite confident in the test suite, but sometimes the user is basically the guy who's doing your QA. And and most of the time we don't care, because our platform is always not that. It's not a bank. It's not an insurance company. It's not, I don't know, some medical thing. So if the user, I don't know, crashes one request, he tries another time, he ends up in a new server, and all is fine. Or yeah, we have basically customer support who deal with that. I mean, there is various businesses in the startup ecosystem where, for example, Wooga, they have a similar approach. Is there anyone from Wooga here? Good. So now I can basically say what I want. No, no, but they say it's fine if the customer crashes the application, we just give him extra gold. We don't care about that. We give him gold. He's happy, and all is fine. If we lose his data, don't care. We give him gold. All right. It's not our philosophy, but yeah. And we try to avoid these things basically. And we also have the philosophy, which is kind of a really old school thing, to never touch a running system. But I heard a lot about Puppet today, or yesterday, not today. And Puppet is basically touching your running system all the time, like most of the time, like, I don't know, once every hour, once every 5 minutes. But if you touch something, it might break. And we don't do that. So in case we wanted to change something, we don't change the actual thing, because we also believe in immutable infrastructure and disposable components. Anyone familiar with that? Oh, a few. All right. That just means never touch your running system, basically. If you want to deploy something, then deploy it somewhere new and replace the old one with the new one. So that means, for example, we don't run Chef or Puppet at all in our application, or on our application. That is all related to stateless things, basically. Your application servers, they should be stateless. They should have no state. There should be no session in your application service. I mean, with Ruby on Rails, it's kind of a no-brainer, because the user brings his session in his cookie, basically, and it doesn't matter where it ends. So we don't need any load balancing. Like, this customer is going to this specific cloud of users. So your application service should be stateless. So it means you can kill them whenever you want, and you just can replace them. So you obviously need some virtualization around that. You don't run in your data center and just destroy the hardware, basically, and get a new one. But probably most of the people running websites use some kind of virtualization technology. Who's not using any virtualization technology? All right, so good proof. So, and we also believe in don't fix it if it can be replaced, which means we don't spend time to get onto these machines and look in the log files, what's going on with this machine. We don't care. We have like one type of machine, and if something's wrong with a specific machine, we replace it. If that is a pattern which emerges, then we look into it. Then we look into one of the machines and figure out, is there something wrong in that machine? But normally, we just throw it away and don't care what actually the problem was. And it works quite nice for us. So we had this one client, so we were also doing the API and the front end and the client application. And we were working with a big German media publishing company, and we were doing a photo sharing app, which means the users could upload photos, and they can rate photos, and yeah, do all kinds of stuff. And there is this media publishing company who creates missions for these photos. They say, all right, we want to have like the funny speech pictures of you, and they have the platform. They have like a big German news website where they can basically announce these campaigns, basically. And we were doing a big bang release, basically. We couldn't do like a soft launch because the customer said we needed to be this really big, and we have like all the channels set up, and we will launch next week or like that on that day. But we couldn't do any load testing before because we didn't know what the customers were like and stuff. And I said, all right, that's fine. We used something like that before. So we said, all right, we pick AWS. No big deal. We can have as many instances as we want, and we were also quite familiar with AWS. We did some larger deployments on AWS, used this AMI-based deployments, which means you created an image and you deploy that to a specific group of servers, like the same thing I just mentioned in the slide before. Then we had our managed load balancer, in that case Elastic Load Balancer, which means we don't care about availability, and we just say, okay, go with these instances. We added auto-scaling groups, which means a group of servers. Basically, if someone goes wrong, just replace it, a new one. So basically we throw away the infrastructure. It's done by AWS for us. And we had like extra things like S3 for image storage, RDS, which is the relational database server for like storing stateful information, because we're not ops people by definition. We don't want to, we are not happy if PagerDuty gets off at like 3 in the morning and you have to fix your database because the disk ran out of space or something like that. We want to give those stateful things to someone who knows how to do that. And so in our case, it would have been AWS. All right, so that was the theory. But in reality, things were a little bit different. Because the first thing was, it was a big public company. There were privacy concerns. So AWS was not an option. And we were like, all right, we're familiar with AWS. We need to find something different to solve that. And if we went for AWS, I would probably be not here speaking about something open source related, because AWS is not actually like an open source company or product. Everyone is familiar with AWS probably, right? Who is not familiar with AWS? Okay, Amazon Web Services, which means basically Amazon gives you instances and infrastructure and stuff like that. All right, so that was the first thing. Said, all right, not AWS. Then we go for a different hoster. There is like OpenStack and OpenShift and OpenNebula and all this kind of stuff. And then we just pick one of those who are similar to AWS, or at least what we needed for them, which is similar. But we were not allowed to pick the hoster because there is something like Lieferantenliste, and yeah, we're really familiar with that hoster, and this guy's really good, and trust us, we run all of our stuff with them, and they're awesome and stuff. And all right, okay, that's good. So then we had a call, and we talked to them, and we found out maybe not the best experts, but they will be fine. They run some VMware virtualization, and we can have images and stuff like that. That's all good. And then they said, yeah, but we don't have an API. And I was like, okay, all right, you don't have an API. Well, yeah, we have a web interface. And said, oh, that's no problem. We scraped a lot of web interfaces before. So then we built our own API. Well, what the heck? And we were like jokingly in private, they will not be using Flash, right? So what was the case? They used some encrypted Flash kind of thing with drag and drop, and it was horrible. And you couldn't even like copy the IP addresses of your instances, for example, because it was some Flash thing where you had to like type the addresses and Ethernet addresses and stuff like that for network configuration. It was, yeah, horrible. Then they also shipped an API. First, as I said, none, and we had to basically deal with the situation that we could launch, because we didn't get any promises when the API will be available, that we could launch without having an API, which means, all right. For our way of doing things, not really an option, but all right. Now we got a proprietary and unreliable API, which means like some requests took like 15 minutes or something like that. So releasing and waiting for your instances and stuff like that, and not the request, but like the request in the virtualization thing behind. Well, there's probably some ticket going on, and so, all right, this customer wants an image and create the instance. Or so that was not an option. So we had, as I said, the Flash-based infrastructure management, which I didn't see before. I mean, there was I think we found out it's VMware. There's a layer on top of VMware which provides a quite like standardized API, and they build another layer on top of that, but they don't give you all the information from the layer below, and they only give you what you actually need to have, they think so. And another problem was limited capacity, which means they said we were like private cloud, but you had like your your fixed capacity and you had your burst capacity, but you couldn't go outside of these. And we were always in the burst capacity when we were running things. And if we needed to increase the burst capacity, they would say, all right, we need a contract for like 12 months, and we buy the hardware for you. It takes you 4 weeks, and then you get the machines. But it's not like if you want to replace all your servers, and this is something with AWS, it takes you like half an hour or something like that. You double your capacity, you throw one part away, and you pay like double the amount of capacity for 1 hour per like day or something like that. And this is just a no-brainer. But we had to have our own image store, so we used React CS, and we needed to update that React thing to a new version, which would have been easy if we just replaced the old cluster or added a new cluster, copied all the data, and removed the old ones. But we had to like replace one by one because we were always in the limits of the burst capacity. Kind of bad. But the baddest thing is we were the biggest customer, and that's something you don't want to be, basically. And with AWS, we would definitely not be the biggest customer. But we were always the people calling, all right, we have some I/O problems. What do you guys think? Yeah, we don't know anything about that. Like, no one is complaining about that right now. But we have them. All right. Yeah, we'll figure out. And then like 3 weeks after that, all right. Yeah, there was some issues, but we don't know why. But all right. So, but we were like the people reporting that, and that was like we switched to a new hoster for image hosting, same thing basically. But I will not name names. If you want to know names, maybe later on. Okay. So, but then the Docker came around. So I stumbled across Docker on I think it was around the DevOps days last year, and this was like, this is nice. You can have basically, or you could have basically everything you can have with AWS with a shitty hoster, basically. That was the first impression I had, so I picked it up, and now I'm here to explain how we did it, what Docker basically is, what it gives you, and there is a lot of people who are also not allowed. Who would not be allowed to run on AWS here? Yeah, okay. So a Docker might be a good fit for you, or a similar setup to what we created might be a good fit for you. All right, so what is Docker? First of all, that's from the website. It is a software who builds, distributes, deploys container-based applications, which means you have most of the workflow to ship your application from your like dev machine to your production cluster. And that's all with one product, basically. So you have some side products, you need some extra for orchestration. Yeah, but that's basically the core principle behind Docker. And important is the container-based applications. So I will talk about that in the next slide. So Docker was created by .cloud, which is or at least was a Heroku competitor in Valley. Who's not familiar with Heroku? Good. Okay. Heroku is like a platform as a service company. You give them your code and they deploy it, basically. .cloud tried to do similar things, much more flexible, like much more different languages supported, but they basically turned into a Docker company in the last year. And Docker was only released like a little bit over a year ago, which means, yeah, really new product, but it got quite a lot of traction. I mean, they got funding and stuff like that, but it's Apache license, but they got like 11,000 stars on GitHub, and I have no idea about the metrics or how good or bad that is, but it's in the top 50 projects on GitHub already, and it's an ops thing normally. I mean, people use it for different stuff. Most of the people will probably not use it in production. Is anyone using Docker in production here? That's good. All right, who is using Docker like in their test staging environment and stuff like that? Oh, okay. All right, they say it's not production ready, but we didn't care. Like we launched in, what was it, September last year or something like that. It was definitely not production ready. It was stable all the time. The only problem with Docker being not production ready is they don't want to like finalize their APIs, basically. So they say, if you go with that version, it's okay. There might be bugs we fix in the next version, but it could also say that we changed the API. But for us, it was not that big of a problem because the API is kind of straightforward, and we said, all right, we picked up enough Go for us to backport these stuff to the old ones. But we didn't have any problems regarding that, for example. Yeah, and it's written in Golang. I heard that you should always say Go. It's Golang is just for like hashtags or something like that. But yeah, it's the Go programming language from Google. The client and the server. Docker comes with a server basically, which is the infrastructure management system on your like specific hosts, and also with a client. But with Golang is like a statically compiled language. Everything is one basically. The client and the server are the same binary. You just started with this is the server flag, and the next time you run it, you have the client. But the client is also just an interface for the REST API. So everything you do with Docker, most of the stuff you do with Docker is just the client. You say Docker run something, it sends an HTTP request to Docker host, and you get basically the result. They moved some parts to the client. I will look at some of them, or at least one part. But normally everything you do with the client, you can also do with your just a REST API client, basically. And it's kind of straightforward. So container virtualization, what is it? And don't blame me on that. I don't know much about kernels and stuff like that. I come from the other side, I said. So it's operating system level. So it means you wouldn't run a BSD system inside Fedora or the other way around, or Windows. And so normally you run Linux inside Linux. And that's where basically Docker is focused. The client application also runs on OS X, probably also on Windows, but it needs a server who's running on Linux. And Linux, I mean, they started with Ubuntu. Debian is also not a problem. I think the Red Hat family of things is also supported, and like Red Hat, the company is investing into going more into Docker and OpenStack and stuff like that. So if you find some Linux, the chances are quite good if you have a recent kernel that you can also run Docker. And also without recent kernels, with some performance penalty, but it's okay. So you have a shared kernel, which means all your containers. Container is similar to a VM, basically, but not quite. They have a shared kernel, so they run inside the same kernel. So you wouldn't be able to run like a newer version or an older version of the kernel inside a container if the host system doesn't support it. It utilizes C groups, which I was told is a Linux kernel extension to isolate CPU, memory, block I/O, and network. Which means you could limit those containers to a specific amount of CPU and memory. And Docker doesn't use all these. I think CPU works, not sure about memory. Block I/O and that stuff, like disk usage, for example, is not supported by Docker yet, I think. But it also like virtualizes networks. But I don't know if that's a Docker thing or if it's a C group thing, but yeah, in theory. So then there is LXC, which is the container technology on which Docker is built, basically, which is C groups plus application namespaces. I don't know how to explain that, but yeah, that's just a theory. LXC, by the way, is the same thing which powers also Heroku, which means if you upload your new code to Heroku, they create a new LXC container for you, similar to what Docker does. But in the end, you get an LXC container, you run that. And some of the things you do with Heroku are similar to how you do it with Docker, and if you do Docker, you find out why some things are with Heroku the way they are, but I will probably explain that later as well. And they are lightweight and pretty fast, but I will show that in the demo. So you have basically two things with container virtualization or with Docker. First of all, images. They are basically blueprints for containers. Good definition to mention something which is not introduce containers, but it's a bit of a cycle. But you can say images are your classes in your programming languages, basically. You create some instances, in that case containers, from these images, but they are just a table of your operation system install packages. So for example, for Debian there is a tool which you can run. You can install some Debian, you can run, and you get a table of all the packages which were installed and which were present without the proc file system and dev file system and stuff like that. And you can use that table just to create a new Docker container from, basically, or introduce as an image. They're read-only, which means you can never change a image. They have like a SHA hashing, which means the moment you change the content, the SHA would also change. So in that case, they're also stateless, and they are layered. And that is a really, really nice thing about them. Basically, basically every image is, you have like one root image, and then you have like child images of each image. As I will show a graph later on. And that means if you have an image, you change something, you create a new image, it knows that it's basically the child of your image, and you can fork, and it's a little bit similar to what your Git branching does, basically. But yeah, just similar. You cannot merge, for example, but in the end, you get a nice tree. So containers. Here's the other part of the cycle. They are instances of images, so you basically start them from images. They use a copy on write, and Union file system who's not familiar with copy on write. Good. So basically, you have an image, and everything you change in the container, only the deltas are recorded, basically, or stored. And every time you access something, you basically go through these layers of, if it's not found here, it's found here. There is some performance penalty with that, but normally it doesn't matter because your applications should be stateless anyway, so it's probably cached in memory somehow. But there was like limitations in the AUFS, it's called. Who knows AUFS?
Due to this, you can do a Docker diff, which is Docker diff, that you can see the difference from.
Yeah. So AUFS, they had a limit, hard-coded 42 layers or something like that. So if you ran into this limit, you had to like merge steps but this limit I think is increased to 128, and it should be good for everyone. So they have a state containers because they're either running or exited, which means you can also start and stop containers. Something we don't do much, but yeah. But in case, they should be stateless and immutable, which means, as I said, disposable components, you shouldn't go into your containers and change something and rely on that everything should be like what you did afterwards. You shouldn't change your containers. You should change your images and then start new containers from them. And you shouldn't also store like data in your containers. Like if you do image uploads, you don't store them in your container, you store them somewhere safe. Because you basically should live with the situation that your container could die any minute. All right. And that can also be saved, which means there is a command which is called docker commit. So you can do manual changes in the container, and then you save that to an image, and then you can use these changes afterwards. So in case that might be a workflow which works, but I wouldn't do it. So, and they're created to be, yeah? The layers are read-only. The containers do the changing on top of the layers, basically. They have their images, and then they use copy and write on top of that. All right, and they're for our purpose, they're created to be thrown away. And this is how the stack looks like, basically. So you have your kernel with these with LXC running, and these are the Union file systems. OFS is the one you need an extra kernel module from. The other one I think is from Red Hat, and I don't know. I don't think it needs a kernel extension. And you kind of two different distributions. That's your image here, and then you have containers on top of that. But the other image is more complex. For example, you have more steps, and but like Debian and BusyBox is a lightweight Linux distribution. They're supported out of the box. All right. So now it's time for horrible things like live demo. All right. So when you see local, it's my Mac here. Docker doesn't run on the Mac, but the client does. So if you expose this environment variable, and you can just install with brew install Docker, and you're ready to go. That's a virtual machine which is running VMware on a Ubuntu locally. So you have the Docker command, which gives you like a bunch of commands. And you have, for example, Docker PAAS, which gives you a list of containers. Let me see. Try to put that a little bit up. I think, where is my mouse? What? Ah, here you go. Damn it. So that should be good. All right, everyone seeing maybe a little bit smaller? Is that okay for the last row? All right. So with Docker PAAS, you can query a list for your containers. Basically, I run 3 of them: one Redis, one MySQL, one Registry. But this is just to play around, basically. And then you have Docker images, for example, where you basically get a list of images. Some of them are, so this is it's called repository. This is the, what is it? Tag, and then this is the image. So you have, for example, this image has just like a couple of different tags. So it's Ubuntu 10.4 and that name, and that is strange. No, it's a different image. Oh, that was a close one. So these are two different images, two different versions of Ubuntu, basically. You can basically say, I want to run a new container. So you say docker run -t -I means I want to have interactive and attached to it, Ubuntu, and you need a command, and in that case I use bash, for example. So that's the time it takes to start the container. So you're in a container, you can do like, it's not that much installed, limited amount of packages. I tried, for example, this guy here. All right, in that case it's good. Back in the days, these wouldn't even have ping. So if you need ping, you install it basically. But you can go here and install stuff. Probably not here because of network, but I prepared that. You have network configuration, which means all the containers, they have a dedicated network address here. So you don't, it means you don't have any conflicts when it comes to ports. So you could have like multiple applications running on port 80 and they all get a different network address, a private one, yeah? Yeah, good one. Yeah, not much. That's your root process. All right. But you don't need to run bash, for example. You could just add run hostname. In that case, it's just giving you every time the container starts, the hostname is the container ID. But that's the time it takes for you to start the container and not throw it away in that case, because those containers are still around. So you could restart the container. They are somewhere here. Played around with it a little bit. Or is it the default throws it away? I don't know, but sometimes they stick around. So yeah. So but that's basically all you can do. You can run them in detached mode. For example, this is the Docker registry. I could run the Docker registry, which is just something I will mention later on, like this. And in that case, it gives you the standard out input. And if I close that guy, then the process is also killed. All right. So as I said, you can start them and you can work with them as with normal VMs, I would say, but you shouldn't. So you also have Docker inspect. Let me see, for example, this guy. What's up with this guy? You have JSON output, so this is the same thing you get from the API, basically. So it's a JSON document with like the full SHA-256 or something like that. So when was it created? You get like all the limitations. You get the environment. You get the command, which was running inside that container. So each image can have entry points, which means entry points define basically what command is run if you don't provide the command yourself. You have volumes, mount stuff, plus, what was that? Let me see. Didn't I go for this one? Normally this should also have an IP address. I have no idea why I'm missing that one. Here it is. So this is your network configuration. You can, what you can also do is expose ports, which means, in that case, this guy's running on port 5000. But if you run the container, you could also say, I'm interested. You can always access that port from your host machine, basically. And you could also probably set up some IP table routing so that something from the outside of the host where Docker runs is routed to a container. But you can also say, if you run the container, I'm interested in that port, please expose that to a local port on the machine. So it does like some bridge kind of thing. So you can also specify, please, this container is the HTTP container where like Nginx is running. So you expose that to port 80 on your local machine, right? And you can do like all kinds of mapping. In that case, for example, I mapped local port or the container port 5000 to local port 5000. And there is also an option where you can mount volumes, which means you can have like shared storage on your local disk. You want to mount inside the container, which doesn't use the layer file system, so the performance is a little bit better. And you can also have multiple containers working with one volume. I don't use that because we don't have state. Yeah, but that's basically the workflow you do, and all that is also possible with the API. All right, so going forward. For us, the deployments are image-based, as I said, and the question is how to build these images, basically. You could start your container, install your packages manually, and you start and attach the container, install required packages, apt-get, install, whatever. Check out your application code in the container. Run your build management tool, which means build management tool as in Bundler or Maven or pip or whatever you use. But it's bad because it's you cannot reproduce it. But I'm talking probably to the wrong audience. If someone is still doing that this way, it will probably be not here because you all use Chef and Puppet and stuff like that, and you automate that thing because you want that to be documented and reproducible. But it's also bad because it doesn't utilize caching, which means Docker also comes with a really powerful caching mechanism. I will talk about in a few slides. And all that is not. If you start the container, basically Docker doesn't know what you're doing inside the container. So there is another option, obviously. So you can use Chef or Puppet, something like that. So you start your attach a container, and you check out your Puppet code, and pull that from Puppet Master, and you run that. But in that case, or Chef Solo, you could also upload your cookbooks and recipes and stuff like that. That's good because it's automated, and it can be automated, and you can document it. But it's also bad because it also doesn't utilize the caching, because Docker doesn't know anything about what your Puppet is doing, and because Docker uses a caching mechanism, which is on the, like 2 slides from now, I think, which relies on your commands basically, which is a bit crazy, but it works. Yeah, so caching is also not utilized, but I will explain that later. So the third option, and the preferred one for us, is Dockerfiles. And Dockerfiles is in the history of Makefile and Procfile and how many Gemfile there is, and there is probably 10 different more. They are simple scripts, plain text, who create images, basically. The available commands are from. So you always provide like the base image you want to run that Dockerfile from, and then there is run commands, which just means execute something. In SH it is, I think. Not sure. You can set environment variables for the execution after that call. Then there is an add flag, which means, or a command, which means you can insert local files into the Docker image when it's created. There is entry point, which defines like what I said before, which defines what is started if you start a container from that image. And then there is various others which I not really use. I mean, there is maintainer. You can say, all right, I'm the guy running, managing that stuff. There is expose inside the container, which is something I wouldn't use because you should decide what to expose at runtime, I think. When you start a container, you can always do that. Then there is command, which is kind of, not sure, do you know more about the command entry point difference?
Entry point is, if you say entry point is bash, then you can only run bash commands.
Okay.
And command can specify some command, and this will be overloaded with the specify command.
Okay. Yeah. Okay. Okay. Yeah, we only use entry point for another reason, because we run upstart with entry point sometimes, and you need entry point with like a specific syntax. But yeah, it's basically the same thing. Then you have user, so you can have user management, something we also don't do. We always run everything as root inside containers. You have volumes. Workdir is just a thing to change your current working directory, something also we don't need that much. And on build, which is a kind of a new thing where you can have callbacks, which I just didn't understand yet, but we didn't have the need to use them. So Dockerfile looks like that. Oh, a little bit unsharp. So to explain, so you have your from statement, as I said, you have your maintainer, then for Ubuntu you always set this Debian frontend non-interactive thing because you want to run that unattended. So you don't want to type Y and stuff like that. And Docker build would also break. This is a hack because there are some problems with init scripts currently. Normally you don't need init scripts anyway. So the first thing I always do is update and upgrade the packages, install that kind of stuff. So that's all Ruby. Who's familiar with Ruby? Not familiar with probably all the Python guys. Okay, and Chef. So this is like your basically your hello world. You install your required packages. I have no idea why. Probably copy paste from some script where I. Now you need them for some gems, I think. So bundle would break if you didn't have them or gem installed. All right. So then you install Ruby. You install Puma, which is like thread-based web server. And you add basically the content here. This is the add file, so that means this local file gets introduced into the container, but it is just a hello world, basically, the smallest recap you can think of. And then you say entry point, and that's basically it. So the output looks like that, or that is really ugly. So in that case, it's all cached. So you say Docker run, you give it a tag, and you run it with your current Dockerfile, and yeah, as I said, in that case, it's all cached, but you see here the caching already kicks in, for example, because all the steps are cached, and you see that. This is the container ID in which the step is running. No, it's not. It's the image which is created. If it's not cached, then you see the container ID. But these are all images, and if you could go here and start that image, and you would have all the steps here executed, but not these here. So they are available all the time, always. Basically. Yeah, so this is quite straightforward, and in the end there is an image you can run. And let me see. I think I called it hello world, Docker run, hello world. Yeah, nice, looks good. In that case it's running on port 80. So let's see, you see, this is the process. But the port is probably not exposed, which means I would need to go into the box. So now I'm on the Ubuntu Linux box and have this container. Need inspect. So here is the IP address. Demo didn't fail me. So all right, so you see, quite nice. All right. So basically, this is your the first part of how to deploy an application. I mean, it looks quite simple. It gets a little bit more complicated, but not much more complicated if you deploy like a proper Ruby on Rails application. There is a few more steps involved. I will show them later, but it's not that complicated, and you don't need like a ton of Chef and Puppet recipes. So a little bit about caching. So caching is statement-based, which means each step creates a new image. So every time you change a step, unless you don't change it, a cached one is used. But statement-based also means if you have side effects, and that's where like Puppet is also a problem, or Chef. If you have like Puppet Master and you run it without any revision or something like that, the first time it would be cached, the second time, the first time it would be cached, the second time, I already run that. But Docker doesn't know that like your Puppet master changed. So you would need to break that and introduce some weird stuff. There is in the slide before were also like two statements which are a little bit complicated because they are also not cached. The add statement, by the way, is caching the content of the file. So every time you change the file, the caching is broken. But what were the statements which cannot be cached or which are bad because they're cached? Yeah. So get update, upgrade are the two ones. They run once and they will never rerun again. So in case of heartbleed, probably bad thing. So, but there is things which you can use to break those, and we'll talk about that. So existing steps, that is the command tree, which already exist are reused. And they're a tricky one, which means non-functional, I call them, because you call something and you get a different result the next time you call it, which is get update, upgrade. There is basically two options. First of all, you can always add a comment to these steps, like hash date or something like that. So, and you change that frequently, and so that reruns basically. Or you just introduce an environment variable before that, and it also breaks the caching then, which means it's working quite well for us in that case. So I said it's a tree. So this is basically how your tree looks like, and that is really bad. Yeah, let me see. Maybe I can. Is that better? Still not sharp enough. So you have your base image here. These are all Ubuntu distributions. So starting from, they were not ordered 13.4. And you see this is your tree, and this is just a subtree. And this is everything in my local machine. And for example, I downloaded this registry, and it comes with a version 0.6.6 and 0.6.7. Which means they forked somewhere here, so you exactly know like which steps led to this one image. Yeah. So and then you have a different branch because it's set on a different base image. Yeah, but this is really, really nice. So you can always see like, and this representation comes from Docker client. This is the one part of the Docker client they moved from the server to the client, which it says you can say Docker images, for example, and then you can provide this, and you can pipe that into your GraphViz and plot your PDF from that. Yeah, so this is what I did. So let me see, Docker images. There is another thing with these Docker images. This is the image ID. There is also a functionality which is called Docker history. So here you see basically all the steps it took to create this image. So it's all reproducible. You know exactly what happened to create this image. You don't need to document anything because everything is baked into the image. And you see these are the like temporary images which are used. And you say, all right, this is nice. I'll just copy these over and start from this one. Then you utilize the caching here. So if you have like something you compile and it takes ages, then utilize the caching basically. All right. Move on. Okay, not good. So configuration management. How to do configuration management? Our approach is to store everything in the environment. And that's a quote from 12-factor. Anyone not familiar with 12-factor? All right. Go read it. It's really, really nice. I think it's from the Heroku guys, and they basically wrote down this is the 12 steps you should use to deploy something. And they store everything in the environment. This is also like the part. Your database configuration in Heroku comes from the environment, for example. So yeah, this is what we also use. So that means the environment is dependency injected when starting the container. So a replication, for example, to connect the database. They don't have any like fixed configuration file and read the database from them, but they just look into the environment. So it means you can also use the same image for development, testing, staging, and production. You can probably also do other hacks, like different DNS setups or something like that. But we're really lazy. We don't want to do that. So we store everything in the environment, all the credentials, for example, which is also nice because they are not in the code and not on GitHub and whatever. And if someone leaks the project or forks it publicly, which happened to us, interesting thing. Yeah. So every time you start the container, say, like, this is the database, this is your Redis here, this is your configuration management, and it's really nice. As I said, you don't need to change these images so they go from one stage to the other, which is really, really nice. All right, so that's configuration management. And then we have some don'ts, at least for us. First of all, no full-blown VMs, which means we don't treat containers as VMs. We don't want to have like SSH running inside them and user management and all the SSH keys and stuff like that. But for us, containers are just a thin layer around a process. So in the perfect world, there is only one process per container. That also means if you have something like we do, we use, for example, Unicorn. We'll talk about that on the next slide or so. You need to have some more stuff inside the container, but your goal should be to have one step, one process. So that also means no SSH daemon inside your containers. That means no syslog daemon inside your containers, normally. Sometimes you need them. We need them because Nginx doesn't do. Why do we need Nginx inside a container of Unicorn? As I said, next slide. Normally no syslog daemons, no user management, everything's running as root. So you don't need your SSH keys, which is also nice because if you add someone to the team or you remove it from the team, you don't need to update anything because it's all containers. The less you put in, the less maintenance you have to do. And if you have, for example, SSH daemon and a syslog daemon, and you utilize these, you also need to monitor them. You need to figure out, is syslog still running? Is the disk space running out of space? And the less you have, the less you have to monitor. And yeah. And as I said, Chef Puppet makes caching useless, which means the caching is really a really nice thing. So a demo about the caching, next slide, is build management tools, is who's using Bundler? Is Puppet using Bundler? No. Just gem install Puppet. So Bundler is one of these tools from the downloading the internet era. So Maven is probably the same thing or something like that. And we'll go with the slides first. So the candidates for Bundler, pip, Maven, Cartoon, Composer, fill in your other tool. The problem with them is that they are basically really slow when they start from a clean slate. So if you didn't do anything, it needs to download everything. I mean, what did I install these days? Something with Maven. And it basically downloaded the internet. But with Bundler, it's the same thing. And the I/O is the problem, and then the packaging sometimes is the problem, and it takes 50% of the time when we build a new image is just Bundler running. So yeah, and it's painful and slow. But the caching is also a problem because every time you change your code, basically your caching breaks. So it would rerun again and again and again and again. And every time you build an image, you would start from all over again. And it's also error prone because if Ruby jumps down, your bundler is breaking, or if you have network issues or something like that. So there is two options. First of all, you can add your manifests before your code. That means you add your code, you can add that with a zip archive, and yeah, so if you add them before, bundler only runs when the code changes. And the other one is use pre-built images. So you can like pre-build on a daily basis, and the build management tool only needs to run the delta, basically. And yeah, you rebuild them from time to time. And the third option is combine both. All right, so Ruby on Rails use case. The problems, as I said, Unicorn. Unicorn only works with fast clients, which means you need to have Nginx running in front of it. You have a problem with static assets because you don't want to serve them from a Ruby process. Logging is a problem because Ruby doesn't log to syslog. Yeah, so the solution is to run 3 daemons inside the container. Unicorn, Nginx, and syslog-d, basically. That's the setup we ended up. Syslog is basically collecting, sending the logs to the local syslog, and it's relaying to a central syslog. And we use it with Upstart or with this entry point guy, and then you can read the end from the proc file, or with Foreman. So. No. Okay. Good. Yeah, so now you have everything set up on your one machine. Now you want to go multi-host. So you can do the image distribution via Docker. Registry, which is a software container you can run and you can pull your images from. And we use weighted load balancing with HAProxy. And we used SSL termination with Nginx. That's a good one. But the good thing is that we were not reliable on ELB updates to be performed, so we just updated them and all were good. So these registries, they are basically something where you can push and pull your images to. There is a public one. You can also push your images to the public one, and it's hosted by .cloud. It's all good. I wouldn't do that probably with my private code. There is also a private one hosted, I think. You pay, and then you can utilize it, but you can also run it yourself, and it comes with backends, local file storage. You can store it on S3 and Google Cloud Ecliptics and stuff like that. So I need to be really quick now, I think. So load balancing. We used HAProxy, light GPL version 2. We stored the pool configuration in Redis. We would use etcd now. So That means to basically do a deploy, we would do a config update, which would mean compile the config files from the store configuration, upload them via SSH to our load balancers, verify the configs on the remote host, and replace the current config with the verified one, and then reload. And this is basically all you need for HAProxy configuration. It's not more, and you need to like create that from your. I mean, these are like two. Let me see. Doesn't work. So these two guys are like two containers, and there were like a few more of them. And this is like your loop which is going, and it's quite simple. And in the end, you get like your HAProxy stats. So our deployment pipeline looked like this. First of all, the commit triggered the new image build. Then the test suite is executed. The image is pushed to the registry. Optionally, you could start an image in the staging environment. Then you can do the last pre-flight tests on the production system, and then deploy that to one host and then to more, and update the load balancer basically, and monitor the new instances. So this is how it looked like. I will. So we had Route 53, the only AWS product, which we load balanced our IP load balanced our Nginx. Then we had HAProxys, various Dockers and containers, and we started here, basically pushed to the build registry, updated them. So I'll skip the logging part. We can talk about the logging part maybe on the thing, and this also on the slides. I'll show the metrics. I store them in OpenTSDB, which is nice. We'll talk maybe later this year on the monitor. Like this is how OpenTSDB looks, really ugly, but we put like Rickshaw in front of it, and this is how our deployment looked like. So this is the moment we started a new revision. So these are the two revisions. They were running at the same time, and then we replaced it with the other ones. So this is one day, basically various deploys, and yeah, this is our dashboard basically. But it's good because I can go into details in another talk then, sometime later. All right, I need to cut here, I think. Yeah, thanks. Questions? Anyway, yep.
Do I understand it correctly? You have the Docker server. You have one Docker server running per physical or whatever virtual real machine.
Yeah.
And if you need multiple servers, you have multiple Docker servers.
Yeah.
How do you, with a Docker client, how do you communicate with them?
You can
specify
that end variable
okay.
with each call, but you don't use the Docker client in these setups. You just use a HTTP client library, and you orchestrate basically with that. Okay. So everything is available through a REST API.
Mm-hmm.
Yeah.
Okay.
Next question.
There was apt-get update,
yeah.
So you do the patch management only when you rebuild the images. So when your application changes, you also deploy the new patches, like for the heartbleed bug.
Mm.
When the application don't change,
yeah.
How do you trigger the updates for the machines?
We don't care that much because we deploy, as I said, multiple times a day. So you mean how often we rebuild from apt-get update?
Yes.
I mean, it's because it's all cached. I mean, the deploy takes a few seconds only. We do that from time to time. As I said, we don't have that many business or security critical things inside these containers. I mean, Nginx, for example, SSL termination is somewhere outside the container, so that's separately updated. So in that case, we don't actually care about the most recent releases. We care about the releases of our software. So Ruby on Rails has much more security bugs than your Linux distribution, probably. So yeah, as I said, we do that from time to time. But as I said, there's no SSH running, so the less you run, the less problems you have with like security issues.
Okay, thanks.
And I think you might work around by providing your own base image, which does this update, and then you build this image every day without caching, and then you have this update. This base image is then, you do not need the update within the Dockerfile.
Yeah, what we also we were generating these Docker files from like a DSL on top of that, but it's not recommended. You should stick to the plain text ones, and then maybe like have a regular basis update, or maybe have your current timestamp. You could, for example, update them on a daily basis and pipe these Docker files through a set statement which replaces like some placeholder with your current date. So you would recreate a new image every day or every week, or depends on what cycle you want to do that, basically. But normally we just stick with the stuff we got. Because the only thing accessible was basically Ruby, and we had hard times fighting the security issues there.
And you said you use the REST API to orchestrate this. Yeah. Do you have to write your own, or do you recommend something that is out there?
For orchestration?
Yeah.
There is a few, I think there is a few frameworks, but most of them I looked in are like, this is Heroku for you running on one host. So there is CoreOS, for example, which is a Linux distribution which utilizes Docker, multi-host, PXE boot and stuff like that, but it's not stable enough, I think, currently. And most of them are single host. So for us, it's not relevant because we cannot do single host. So yeah, we build the orchestration ourselves, but it's really, really simple, basically. So the HAProxy is something you need to generate from your config, and the SSH scripting around is not that hard. And use Golang for that, which is really, really nice language for that.
And if I may, I have a talk at 5 p.m. which uses Docker as well. So if you get hooked by Tobias, then you might want to swing by.
Cool.
Okay, thank you very much, Tobias. The next talk in this room will be about